When muscles contract to perform actions, they always work together to result in a smooth, efficient movement. And when muscles do work together, they're going to perform one of four different roles. And those roles can be the agonist, the antagonist, the fixator, or the synergist. And this information is highlighted for you on the coloring book on page 45. So we'll take a closer look at each of those four actions and give you an example of how they occur. So the first action we're going to look at is called the, let's see if I can get this all on the same page here, there we go, is called the antagonist. And this is a muscle which contracts to produce the movement. Antagonists may be referred to as prime movers or assisting muscles. So an agonist is simply defined as a muscle that contracts to help produce the wanted movement. Now, the biggest muscle or the most efficiently placed muscle will be defined as the prime mover. And that is the muscle that supplies the most energy or force into a particular contraction. And an example of that right here is called the triceps brachii in the action of arm extension, which is bending your elbow to straighten your arm. The triceps brachii is considered the prime mover because it is by far the largest muscle on the back of the arm, back of the upper arm. And it is the one that has the best position and largest size to produce the most force in elbow extension. However, a much smaller muscle located close to the elbow joint is called the anconeus. And the anconeus is an assisting muscle, so it helps assist in that action. It is by no means, though, the largest or most efficiently placed. So the prime mover of this elbow extension action is the triceps brachii, and the anconeus is also an agonist, but it is an assisting muscle or a secondary muscle or a minor muscle in that action. So every action has an agonist or multiple agonist muscles, but just about every action also has antagonistic muscles. And an antagonist is a muscle which opposes the movement. And again, looking at the simple action of elbow flexion, we talked about the triceps being the prime mover in the action of extension, extending that arm, but there are muscles, primarily the biceps brachii, which oppose that action. So when you have the action of extension, the triceps is concentrically contracting and the biceps is relaxing to allow the triceps to do its work. And the opposite also occurs here. When the action of flexion occurs and you bend your arm, the biceps becomes one of the prime movers within that action due to its size and position, but the triceps then plays the role of antagonist, and it has to relax in order for flexion of the elbow to occur. So when one muscle is doing its thing, opposing muscles have to relax to allow that muscle group to do its thing. So the opposing muscles are called antagonist muscles. There is another action which is very effective in a number of joints, and it is the action of a fixator. And a fixator muscle is a muscle which stabilizes more proximal joints during movement of a more distal body part. And a great example of that is looking at the trapezius and rhomboid muscles in any action of the arm. When you are applying any action or force or movement of your arm, these muscles that actually move your arm pull on the scapula. And the scapula needs to be a strong, solid base for these muscles to apply their force effectively. So the trapezius and rhomboids, which are attached to the scapula in this position, they lock the scapula in place, and they allow then the smaller muscles of the arm to do their job, to contract, to move the arm. If this base of the scapula was not contracted and not locked in place due to the fixators, because the arm itself is larger than the scapula would want to move towards the arm as opposed to allowing the arm to move based on the smaller scapula. So fixators will fix or stabilize a more proximal joint in place, in this case the scapula, to allow other muscles to do their thing. And our last example here is synergists. So when undertaking a desired motion, undesired motions are resisted by muscles which play the role of a synergist. These muscles eliminate unwanted secondary motion to more efficiently apply the full force of the desired motion. So in the example here, what I'd like you to do is listen to my instructions and follow along. So I'd like you to bend your right arm at 90 degrees. I would like you to take your index finger from your left hand, put it in your fingers of your right hand, and then squeeze that finger as tight as you can with your arm bent at 90 degrees. So again, your right arm bent at 90 degrees, and you're squeezing the finger of your left hand. So I want you now to think of the pressure that you're applying to that finger. You should have a pretty good grip. You should be able to squeeze that finger quite efficiently. Now what I'd like you to do is bend or flex your wrist all the way forward on your right hand. So on your right hand you have your arm, elbow bent at 90 degrees, and you have your wrist flopped forward. Now I want you to try and squeeze that finger on your left hand again as tight as you can. And you should see a very significant drop in the amount of muscle strength you have. So what's happening there is the muscles on the back of your forearm are locking your wrist into a straight position. So those muscles on the back of your forearm are playing the role of synergist, and what they are then doing is allowing the flexors on the front of the forearm to apply their force efficiently. If those flexors on the front are not opposed by the synergists on the back, they flop the wrist over, and then they eliminate a lot of the slack in the muscle, and that greatly reduces the amount of force they can apply. So I hope that example worked for you, and I hope you understand how a synergist work. So they eliminate undesired motion so that the actual muscles you want to apply can apply their force more efficiently. Now, within group actions of muscles, there's also a concept called reciprocal innervation. And what that is the contraction and relaxation process between opposing muscle groups needs to be done very smoothly. So when you are flexing your arm, the opposing antagonist muscles need to relax at the exact time and with the exact amount to make that action smooth and continuous. If the muscles on opposite sides of a joint do not perform reciprocal innervation smoothly, you're going to get very herky-jerky motions during contraction and relaxation. So those two muscles coordinating, allowing one to contract while the other relaxes, is called reciprocal innervation. And again, that stuff will be on page 45 of your coloring book.